Next we're going to be dealing with square roots and radical notation. It's really important that you understand the notation. Just like anything you've been learning in math, you are learning a language as well as anything else. So when you see expressions like this, you need to know what they mean. Okay? So something to consider, at this stage of the game, we are only going to be looking for real numbers that simplify or that meet the conditions we're looking at. Or here, when I'm talking about, if I'm asking you to find the square root of 25, I want you to find the real number that can be multiplied by itself to get it. So this notation, the square root of 25. This is notation that we use to represent a number that can be multiplied 2 times to get 25. If it is a square root and there is no number here, it's called a square root. Okay, it is basically an understood 2. So if you want to, this notation asks you to find the real number that can be multiplied twice to get 25. Okay? And something else to consider, you can multiply positive 5 by positive 5 to get 25. You can also multiply negative 5, which is also a real number, twice to get 25. We only want the positive root, which is also called the principal root, when we're trying to simplify these. So not only do you want to find the real number, you really want to find the positive real number that can be multiplied twice to get 25. So that number is 5. These are equivalent notations. This represents something I can multiply twice to get 25, as does this. This is the simplified version of that. Okay, here I want to find the opposite of the square root of 25, or it can also be read as finding the negative root of 25. Either way, the opposite root of 25 or the negative root of 25, those both, that is negative 5, right? The square root of 25 is 5. The opposite of that is negative 5. And then finally here we want to find the square root of negative 25. So we want to find a positive number I can multiply twice, a positive real number I can multiply twice to get negative 25. And if you know anything about multiplying positive and negative numbers together, we know that if we multiply a positive number by itself, that the product will be positive. We also know that if we multiply a negative number by itself, that product is positive as well. So if there is no real number, positive or negative, that we can multiply by itself and get a negative, right? If we multiply a number by itself, then we would be multiplying basically 2 numbers that have the same sign, and that product would always be positive. So the square root of negative 25 is not a real number. We'll discuss later what the square root of negative 25 is, but right now we're only looking for real numbers that we can multiply, and in this case, a real number does not exist. Okay? So that's just kind of a little bit of an introduction to the notation. So if you're looking for the square root of 25, you're looking for a number that can be multiplied twice to get 25. Okay? Whatever number is here, and if there's no number, it's an understood 2. That's how many times you want to multiply a single number to get the number that's inside, which is called the radicand. Okay? So using that same logic, or understanding the notation, if I want you to simplify or evaluate the cubed root of -8, this index of 3, that's called the index, says find a real number that we can multiply 3 times and get -8. So it has to be the same number multiplied 3 times to get a product of -8. And so if you think about what this could be, so we have to think, is there some number I can multiply 3 times and end up with a product of -8? Okay, if you're just thinking about the sign, first of all, is it possible to multiply the same number 3 times and have a negative product? And that answer is yes. If you multiply a negative number 3 times, the product will be negative. So this can work in terms of sign. Now let's think about number. So trying to find a number that when multiplied 3 times gives us 8, that number is 2. If you do 2 times 2, that would be 4, and 4 times 2, that would be 8. So we can see if we multiply this number 3 times, we get -8. So therefore, the cubed root of -8 is -2. Okay, so let's write this down. So this notation, find or simplify the cubed root of -8, we are looking for a number that can be multiplied 3 times for a product of -8. Okay? So the index is important. It's just as important as the radicand itself. Okay? So I guess I wrote that already. Well, there you go. You didn't need to write it twice. Looking at this next slide, so we want to simplify each of these, and to do so, you know, in the most simple way at first, we don't know what A, B, or X represent, but we are going to take negatives out of play here in terms of our variable parts. So we're always going to assume that our variables represent positive real numbers. If we did not make that assumption, then we would have to include absolute values in our simplified expression. And for now, we just don't really want to go there. Let's just look at the simplifying aspect first, and then we can, you know, at a later date, talk more about introducing, you know, if A could possibly represent a negative number, how would that change our simplified expression? Okay, so for now, I want to simplify the square root of A squared. So I want you, if you can, and that's always, you know, if you can, find something. So no index means it's an understood 2. So find something that you can multiply 2 times and end up with a product of A squared. Okay? So let's write that again. you can never write it or think about it too many times, because understanding the notation is hopefully what's really going to pull you through. So I am wanting to, so again, this is just an understood 2 when it's a square root. Find something, or we can say an expression, right? We can't find a number. Find an expression that can be multiplied twice to get a product of a squared. Okay, so I have to think, what can I multiply 2 times and end up with a squared? And you're multiplying the same thing twice, don't forget that. And based on what we know about rules of exponents, we know multiplying exponential numbers, we know that if we multiply a by a, we get a squared. So the square root of a squared is a. The number that I can multiply twice to get a squared is a. Here, find an expression that can be multiplied twice to get b to the 10th. So what can you multiply 2 times and end up with a product of b to the 10th? So again, knowing what you should know at this point about multiplying exponential numbers, you should realize that if you multiply b to the 5th by itself, that product is b to the 10th. Multiplying exponential numbers with the same base can be accomplished by adding the exponents. B to the 5th times b to the 5th is b to the 10th, right? Or if you think about what this notation means, b to the 5th says take b and multiply it 5 times. Then you would take and multiply by another 5 b's to have a total of 10 b's multiplied. So b to the 5th times b to the 5th is b to the 10th. That looks like a not equal to. I'm not quite sure how that got in there. Let me erase that. Okay, b to the 5th times b to the 5th is b to the 10th. And therefore, the number that I multiply twice, or the expression that I multiply twice to get b to the 10th is b to the 5th. So the square root of b to the 10th is b to the 5th. And finally, I want to find the square root of 49x to the 16th, or find something that I can multiply twice to get 49x to the 16th. So if we think about this, think about the 49 and the x to the 16th individually. Is there a number that you can multiply twice to get 49? Yes, that number is 7. Is there an expression you can multiply twice to get x to the 16th? Yes, that number is, or that expression is, x to the 8th. So if I multiply, you can verify, if I multiply 7x to the 8th by 7x to the 8th, the 7 times 7 is 49, and the x to the 8th times x to the 8th, the 2 8s add to 16. So the square root of 49x to the 16th is 7x to the 8th. So if you go back through, it's pretty easy to see that if you're simplifying these square roots, when you're dealing with expressions that have powers, if this power is divisible by this index, you can take this power divided by this index and end up with the square root of a squared, right? Index 2, power is 10. 10 divided by 2 is 5. So b to the 5th is the square root of b to the 10th. That does not work for numbers, right? If you do 49 divided by 2, you do not get 7. So this division, that only works for powers. This power divided by 2, this index, is x to the 8th. The way, you're just going to have to know some of your basic multiplication facts, or you can learn how to use the square root button on your calculator. And I am more than happy to help you with that. So if you need help with your calculator, please let me know and I will show you how to work the square root button. Doing more. So really, before we go on, let's just kind of do a nice quick review on some of, your basic perfect squares and some of the first few perfect cubes. It's very important. You should be able to recognize at least the first 15 perfect squares. If you see 36, you should know that that is a perfect square. If you see the number 100, you should know that is a perfect square. And because I would multiply 10, but can multiply 10 by itself to get it, then the square root of 100 is 10. So all of these numbers are perfect squares, and the square root is whatever number is here. So 169 is a perfect square, and the square root of it is 13. 196 is a perfect square, and the square root of it is 14, etc., etc. Like I said, you can use your calculator, but if you can recognize them, it's going to make your life a whole lot easier. Over here, let's talk about variable expressions for a minute. So if I multiply, let's just say x by itself, that product is x squared. So because I can multiply something twice to get this expression, this is a perfect square. And the square root of x squared is x. If x is again, we are going to make the assumption that x represents a positive real number. If I multiply x squared twice, x squared times x squared, 2 plus 2 is 4. So if I multiply x squared 2 times, the product is x to the 4th. So x to the 4th is a perfect square, and the square root of it is x squared. If I multiply x to the 3rd twice, that product is x to the 6th. If I multiply x to the 4th twice, that product is x to the 8th. If I multiply x to the 5th by x to the 5th, that product is x to the 10th. X to the 6th times x to the 6th, the 6 plus 6 is 12. And you can keep going on and on and on forever and ever and ever. What I'm wanting you to get out of this is, when you're dealing with an exponential expression, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, etc., etc., etc. If the power is even, then that represents a perfect square. So when you're working with exponential expressions, you can recognize a perfect square by an expression with an even power. Okay? So if the power is even, or we could say divisible by 2, so if the power is even or divisible by 2, we do have, it is a perfect square. Okay. Similarly, when dealing with perfect cubes, most of you are probably more familiar with some of your perfect squares than you may be with your perfect cubes. Again, I can show you how to find cubed roots on your calculator as well. So, don't let that be a concern, though it is helpful to have some of these, perfect cubes in your brain for quick recall. So especially 8, 27, 64, 125, really the first 7, you should realize, that 216 is a perfect cube, that 343 is a perfect cube, and that the cube root of 343 is 7, right? The fact that I multiply 7 3 times tells me to get 343, tells me that the cube root of 343 is 7. When I'm working with variables, so let's think about multiplying something 3 times. So if I multiply x 3 times, x times x times x, that is x to the 3rd power. If I multiply x squared 3 times, 2 plus 2 plus 2, that is x to the 6th. So x to the 6th is a perfect cube, and the cubed root of x to the 6th is x squared. Okay? If I multiply x to the 3rd 3 times, I would get x to the 9th. So x to the 9th is also a perfect cube, and the cubed root of x to the 9th is x to the 3rd. So if we keep going along in the same manner, looking at our first few perfect cubes, so 4 plus 4 plus 4, that's 12. So x to the 4th multiplied 3 times is the product of x to the 12th. X to the 5th multiplied 3 times, that's x to the 15th. X to the 6th times x to the 6th times x to the 6th, that is x to the 18th. X to the 7th times x to the 7th times x to the 7th is x to the 21st. And again, you can keep going on forever and ever and ever. So if we look in the far right column at the perfect cubes that we've found so far, x to the 3rd, x to the 6th, x to the 9th, x to the 12th, x to the 15th, etc., 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 you should see that the pattern emerging is 3, 6, 9, 12, 15, 18, 21. This would be 24. This would be 27. On and on and on. When you're dealing with exponential expressions, if the power is divisible by 3, then you can recognize that that is a perfect cube. Okay, so if the power is divisible by 3, then we have a perfect cube. All right? And the cubed root of it, the cubed root of x to the 21st is x to the 7th. If we divide that power by 3, we can find the cubed root. If we divide this power by 3, we can find the cubed root. So the cubed root of x to the 18th is x to the 6th. If you are working with, 4th roots and 5th roots, it's the same scenario. If you're trying to simplify a 4th root, then your powers would have to be divisible by 4 to be a perfect 4th power. If you're trying to simplify a 5th root, it would have to be that your powers are divisible by 5. Okay? So let's look at using this idea. Let's look at this next example. So if I want to simplify this expression, again, making the assumption that x represents only it can only represent a positive number. If I want to find the 4th root of x to the 32nd, then I'm going to try to find an expression that I can multiply 4 times and get x to the 32nd. So, does it exist? The easiest way to figure that out, or the answer to that, is easy. Is 32 divisible by 4? Yes, it is. 32 divided by 4 is 8. So there is something I can multiply 4 times to get x to the 32nd, and that is x to the 8th. So the fourth root of x to the 32nd is x to the 8th. If I multiply x to the 8th 4 times, I will get x to the 32nd. Right? Let's write that down. If we multiply x to the 8th 4 times, we will get x to the 32nd.